2 of Mission Control. This is just exciting. I can't believe we're here. Well, I got told yesterday that since I had a presentation today, I had to ensure that I was loaded up on memes for my presentation, or else I would not have a legitimate presentation. I was told that by someone. So we're going to wait for AV to click over, and there we go. Whitney, this is for you.
Don't let Whitney bully you.
So the very first meme talks about the last system administrator leaving the cloud. But nonetheless, I put this together. I was asked to speak on something a little bit recently, I will say. So I wanted to put together this thing that's kind of been rattling through my head for a little while, especially when it comes to the things that we build, the things that we architect, and how we offer them up, and then how people consume and use them as well. So this talk is all your cloud infrastructure belong to us. And if you've been around in threat actors and adversaries and whatnot long enough, you know exactly where this is from. If you're a fan of horrible Japanese anime, then you really know where this is from. But nonetheless, we'll leave that off to the side. Oh, Whitney, there's another one for you as well, just in case. But I want to center on this idea here for just a moment, because there was this concept, this thought for a long time, that cloud computing was designed to make security more accessible. It was inherent, it was built in, it was just there. It was much more secure that I didn't have a physical rack sitting there that someone could walk up and just approach and do whatever they wanted to. And unfortunately that's really it's rooted in a lot of legacy thinking about the way that we go through and protect and secure networks and things like that. And it's led to, I think, a lot of issues for a lot of organizations as well, because it's almost like the blind leading the blind. There is no inherent security in a cloud platform or in cloud infrastructure right now. Yes, there's some, I'm aware. I can configure IAM policies. That's not inherent. It's work I have to do. I can go and set up and build something and deploy something, and there's a little bit of security because there's an automatic firewall, right? If something happens to my container, Microsoft will protect me because it's in their data center, and their data center is not going to get attacked like my data center would. So there's an inherent understanding or assumption there. And unfortunately, that just isn't the case. The other side of it is that we also run into, and I tried to coin this last night. I don't know if it's going to work or float, but we'll see if it does. I'll let you all tell me if I'm way off or if I'm on the mark here. But I came up with this idea called the cloud benefits paradox. And it's definitely pivoting adversaries against defenders in this case. And when we think about the cloud, and when businesses think about the cloud, and when people think about what the cloud gives you, really at the end of the day, we're talking about faster development and faster go-to-market. We're talking about doing things much faster. Profits go up. I'm able to build applications in days rather than weeks or months. I'm able to deploy. If someone needs something on Thursday, I can give it to them by Monday because I don't have to wait for the infrastructure, for the platform, for the functions, for the whatever to be created. But I had to step back, and as I was building this out, I was starting to ask myself, well, who is it that benefits from more development and go-to-market speed? Is it the business that's building the thing, or is it the adversary that's using the cloud? And this is where I got stuck into this idea of a little bit of a paradox here, which is if we can build it faster, so can they. This is the tough part about this. If I'm able to deploy an application tomorrow, today, within 5 minutes, then so can my adversary. The more benefits, the more features. Anyone here ever walked through the AWS laundry list of what they can provide? Every single one of those is a benefit that streamlines someone's operations somewhere. I didn't say whether those operations were good or bad, but it streamlines their operations, and that's got to be an important consideration. But this feels very elementary, so I tried to make it sound more official, right? A benefit received by defense is equally a benefit to offense as well. And I don't know if this is going to stick or not, but it's something that's kind of stuck with me for quite a while now as I've watched and observed threat actors do what they do, is this seemingly gap in security thoughts that, oh, well, most of my adversaries, and we're going to look at an adversary that does this in just a moment here, most of my adversaries are traditional style things. So I need to invest in all the endpoint software I can. I need to protect all the physical assets that I can because that's still where the users are. And if that's your way of thinking, or if that's your security team's way of thinking, it's time to kind of wake up. And that's a really harsh reality for some folks to consider, to think about, primarily because that's not the focus of a lot of adversaries these days, and we'll talk about what that looks like for a lot of them. But furthermore, every single year, there's a conference from some sort of cloud offering somewhere, and they talk about all these new things, lower cost, deployment of this, we can now do that, everything can be templatized. Do you know how amazing Terraform is to an adversary? It's expensive to prop up and maintain C2 infrastructure. It's expensive to rotate domain names and IP addresses. It's expensive to hop from cloud to cloud to evade defenses. Not anymore. It's now easy, it's trivial. I can link these different benefits and link them together. The other important consideration here is the more cloud we have, the more attack surface we have. Now, let me just pause before anyone takes a screenshot of this. I am not standing here and advocating saying we need less cloud. I think we need to change our approach towards this. And when I say our, I mean from a security perspective around this. Because our cloud providers are not. They're not going to all of a sudden say, you know what? It is time that we get secure. We're going to turn these things on by default for you. If anyone here a Microsoft 365 user or has experienced the security side of Microsoft 365, it took years for them just to turn on rules that offered simple logic-based detection. And of course, they wrapped it behind a subscription wall. Years just for that. It is literally free logic. And I'm not using this to throw shade at them. I'm using this to highlight the point of their security or your security is not their priority. And that's just the fact of the matter is. Guess why? Because the most successful, most lucrative, most profitable attacks out there, they live off of this. They live off of our cloud infrastructures now. They use it to their advantage. That's how they make the most money. And if you want a shining example, we only need to go back a month in time to that wonderful hacker summer camp city of Las Vegas and say, if you're looking to make a quick 10 million bucks, it's a 10-minute phone call and you're done. That's it. It's a 10-minute phone call and then abuse of the cloud. And I'm really simplifying that attack. But I'm trying to highlight the point that that's where adversaries are. That's where we should be thinking as well. And I went a step further and I kind of made this decision that the cloud doesn't expand any one attack surface, it redefines it. It redefines it because we now have to think in terms that we didn't have to think of before. I like how yesterday Max said in his talk, Microsoft 365 is not an endpoint. Speaking from that particular point of view, 100% correct. But take a look at what it does when attack surface management redefines. These are all sales points. These are bullets in brochures that tell you that they will make your life easier. These are things you can buy, you can subscribe to, you can go drop a credit card in for, you can do all sorts of amazing things against and do it fast. You want to build, scale, deploy, or not worry about anything? We got you, you're covered. Guess what? Every single one of these is also an entry vector as much as it is a product. And again, I'm advocating for security teams to say, wait a second, I can scale as fast as I want to, so can my adversary. Again, that paradox pops up. I went through and had fun putting a bunch of different random acronyms together because sometimes I forget just how big of a scope this industry actually is. But when you get into everything, infrastructure, platform, software, functions as a service, every single one also has its own little trees that branch off. Whether I deploy a private, public, community, or hybrid cloud, every single one has its own little trees, own considerations that I've got to be aware of. Again, are these products or are they entry vectors? And more importantly, how is a security team evaluating those different sides? So this is going to be probably one of the most, yeah, Matt, I'm aware of this type of moments right here, and we'll spend just a couple minutes looking at some of what the top risks to cloud infrastructure are. But after this, I'm going to walk you through some threat actors who figured out a way to thread the needle in between these things. One of the biggest ones out there is just simply knowing what you have, asset and awareness. As odd as that sounds, how many dev, and I don't want anyone to raise their hand for this, but how easy is it for me to go spin up an EC2 instance? I need a what? I need a credit card, and I'm done. That's it. I need a credit card, and I can spin up something that can be used and weaponized against my organization. I no longer need access to a physical data center. I no longer need all the different controls, administrative accounts, and everything like that. I can pull a Git branch down to my laptop, use my credit card to spin up an EC2 instance, and mirror an application. No one's the wiser. Until hopefully someone's got an eye out there saying, wait, this thing is not legitimate at all. I can also go a step further and say, if I have administrative privileges inside of a cloud infrastructure, what can I do? And I have to turn that question around and say, what can't you do inside of that? We'll talk about a threat actor that abuses this in just a moment. Second biggest risk that I see in a lot of the things that I analyze and folks I talk to are data flows across and between clouds as well. It's funny, I know that there's like the big three that are out there that a lot of folks use. However, there's a bunch of little, I'm not going to say small others, because I don't think DigitalOcean is a small company, but they are not AWS, right? Let's be clear. But do they pose the exact same infrastructure risk? Absolutely, 100%. DigitalOcean, Linode, all those other VPSs that pop up all over the place. And more importantly, there's other VPSs who find a lot of success because of where they're geographically located. Those also introduce another element of concern for us. AWS, I would like to assume, and we would all like to think, is going to carry some sort of inherent legal requirement behind it, that it's not operating in an embargoed nation or providing services to an embargoed nation. But I'll tell you what, the further you go around the world, country borders get real thin, and money slides really, really far in some of those locations. So data flows across and between clouds really opens up a lot of doors for a lot of organizations, because sometimes they, again, I want to build fast, I want to go to market, I want to deploy a thing. The number of ads I've seen where someone wants to give me a free VPS for 1 to 3 months just to test out and see what happens is, quite frankly, N+1 is more than enough. This is the biggest one because of how many permissions we give. And it's funny, this is not a new risk or a new concern in the world of computing. Having insufficient identity and access management or too many privileges or too many things is not something unique and new. This has been around ever since computers have been a thing. It's funny, the early days of computing, everyone on the computer was given trust. There was like 5 people on the internet, and all 5 of them knew each other. They were all academics, and everyone had the same privileges. And now we're at this point where an industry, an entire multi-billion-dollar industry, is realizing maybe we shouldn't be giving people that much trust. It doesn't extend that far, and it's easily abused. Identity hopping is the one that I see adversaries using a lot these days, and this one's pretty straightforward. This is SSO abuse. This is federated account, federated access abuse. If I have access to one, I have access to many. And then the last couple ones I have in here, credential theft is in line with, I think, access management policies and things like that. But the big takeaway for credential theft, and we're going to look at this one in just a second here, is just how easy it is to get those. For me, identity hopping is a result of, or a byproduct of, a credential theft. And last but not least, my last two, insecure APIs and misconfigurations, which again work in tandem with each other. These are really, really complex issues that are actually quite easily solved in some cases, but in other cases, they are very, very easy fixes that are solved in a very complex manner. And I'll break both of those down momentarily as well. All right, so I wanted to spend a couple minutes as part of this as well walking through adversaries who actually have figured this out a lot better than the rest of us have. And I don't mean any insult or any shade to anyone in here, but when you walk through some of the attacks I'm about to walk through, you're gonna see these guys have this figured out. I grabbed some stats for this, and I'll ask an interactive question in just a moment here. Cloud attacks happen fast. There are many, many folks out there. By the time you've gotten an alert and processed that something has happened, you might be behind the curve, number one. 90 to 95% coverage is not enough. All it takes is, and I hate this word because it was used for years and years, but honestly, 1-5% visibility gap, 1 to 5% security gap, that's their way in. Cloud attacks usually target cloud providers. Not, and let me be clear about that, they may target an industry or a company that utilizes an infrastructure service. But if I go and target an AWS instance, yes, the ultimate goal might be who owns that instance, but the thing I'm targeting is the underlying service that you're using. And then I also found really interesting here the dwell or initiation time of an attack. So for anyone who's been around adversaries or been around kind of this security thing long enough, how long do you think this is? 2023, September 2023, any thoughts on how long it takes for an adversary to initiate an attack to getting in a cloud environment? Any guesses? I'll take anything at this point.
An hour?
An hour? Anyone else?
5 minutes.
5 minutes? Who said 5 minutes? 5 minutes, okay. Anyone else? All right, Paul's the closest. 10 minutes. 10 minutes from initiation to kicking the door in and being good to go. 10 minutes. Did you read this report, Paul? Is that how you know? First threat actor I'm going to pick up on is going to be one called Scarlet Eel. This is a threat actor that I have read about when they first came out with this blog, and I was just absolutely blown away at the way that they do this, because it sounds a lot like what we do as developers and engineers. Look at that entry vector. Vulnerable Jupyter Lab notebooks are how they break their way in. I went through and I kind of mapped this out a little bit. They hop from vulnerable Jupyter Lab notebooks, dropping into, and I'm going to map this out here for us, using that to exploit their way up to the Kubernetes cluster that's being used to manage those. From the Kubernetes cluster, they look for AWS credentials that they can use to subsequently abuse. Anyone know how to pull AWS credentials out of an instance that you're running inside of? There's a magic IP address. There's a magic IP address up in AWS that you can use to query for metadata about the instances that you're in. Honestly, be honest. Raise your hand if you didn't know this existed until like this moment. Adversaries knew it. Adversaries are in there, and they know if I write queries against this thing, they roll in with shell scripts that query this IP address, hit that magic value back, and there's a particular type of file, a particular type of link they're looking for, which are cred file names. Cred file names points to all the existing credential file names, hence the variable name, that are in the background. Grab those, you now have access to the various instances, time to profit, time to make money. All those skills just to run a crypto miner. The next one I'll take a look at, this one, we can't talk about cloud threats without mentioning this one here. This is Scattered Spider. Anyone heard of these guys recently? I hope so. I definitely hope you've heard of these. Group is very, very well versed in AWS and Azure and how those different services work. And when I say an attacker or an adversary is well versed, I'm not talking like the junior person on the team sat through the free training and maybe got their cert. I'm talking they breathe it as much as DevSecOps people, as DevOps people breathe it. They understand the scope and depth of federated access and identity management. And then last but not least, and I just dropped these two names in, it is not their entire repertoire whatsoever, but the ones that are catching the most news coverage right now are obviously MGM and Clorox as well. I went and grabbed the entire adversary lifecycle for Scattered Spider because I wanted to prove a point about the way a lot of security works these days. A lot of security looks at the end and says, okay, so what can we do to catch these types of things? How can we find out how they do what they do? How can we detect things like lateral movement? How can we detect things like internal reconnaissance? And my biggest issue with this thought train and these types of approaches here is at this point, you're far too late in the game. Far too late. I've said for years, if you're detecting a ransom note and that's the way you find out you've been ransomed, you're far too late. But honestly, some of you may find this hard to believe, that's an improvement. Because the detection mechanism for most organizations used to be, I got a phone call from someone who has my data. So imagine that this is already an improvement, but for me, this is still too late. Then we'll focus a little bit more on the middle part of the attack and say, oh, well, let's see how they're gaining access into the environment. They're coming in via remote access tools. Let's go ahead and lock these things down and secure them so that way they're not abused so much. And again, I still think we're too late. You're way too late in the process. We need to be here. We need to be here because this is where they found success in those big profile breaches. MGM, Caesars, it was right here. This is where the adversaries found success and knew that they had it because the rest of this stuff from the red onwards is automated. It's automated, it's tools, it's buttons, it's things you click, scripts you type, you're set. The real work is right here. This is where they're digging in. And this is where the adversary also has the ability to pivot and shift as much as they need to. This is also where you can lose the most, the fastest. It's not when they run a ransomware script. It's when the help desk inadvertently gets tricked into giving a root access account out. That's it. Game over from there on in. So when I focus on adversaries and think about what are some things or ways we can go about kind of mitigating against this, I'm here. And I'm talking more to folks about, all right, you now have access to a lot of different resources. You have access to things that can really damage the organization if used or abused. We're going to train it here. We're going to start here and talk about things that, I'm not talking about 4 or 5 mechanisms to give these passwords out. We don't give these out. They're never given over the phone. It is a physical transfer. It's a physical login if need be. I'm working to educate and say that the accounts that can really harm and damage us, they're not given out in certain ways that I know can come back and impact us. And before anyone comes back and says it, I'm not throwing blame on any users whatsoever. I think as an industry, we've got to get better at either securing these assets or securing the way that they're given away. The last little one I'll pick on here, and this one is a real brain twister, is Amber Squid. Again, I don't pick the names, I just read them and make fun of them and then comment on them for what they are. But this one right here is really going to take you for a ride. In case anyone is curious, this is their attack workflow, and it does start from Docker Hub, where they eventually get their way into AWS, and this group takes advantage of Code Commit, Amplify, EC2, SageMaker, ECS, CloudFormation, and Code Build as part of their attack. So if you're familiar with AWS, that's 7 names, 7 products, 7 logos that they take advantage of. Before I get into it, because I do have this a little bit later on, anyone here familiar or built on top of AWS or knows AWS really, really well? Any idea why I would pick those services and not just EC2 at the onset? I'll say it later again. When you drop in requirements into AWS that require you need to notify someone for scaling, you need to notify someone for charges being upped, or you need to notify someone that, hey, the instances are getting bigger. A lot of times EC2 is the one that gets put in that category. These other services, and this is what the attackers found out, other services were not. So they were able to build and scale infinitely if they wanted to without any notification to the account owner. So they targeted, and as I mentioned, they targeted cloud services without AWS requirement for approval of scaling. Now imagine that, let's just start right there. My adversary already knows how to target an environment and find things that don't require approval for scaling. I don't know how many AWS developers know that that's a requirement or know that that's a thing inside of it. This again speaks to what the adversary is doing. So malicious Docker containers stored on Docker Hub, those pivot into AWS credentials and roles, and then just walk through this with me here. They take those roles and they push and create roles out for AWS Amplify. They then attach roles to Code Commit, CloudWatch, and Amplify. From Amplify, they spawn SageMaker. SageMaker is then also utilized as part of it. They'll use those credentials to spawn ECS. ECS goes into Code Build. That's where the actual miner shows up. All of this, and all we've done so far, is assign roles and start to build out services and deployment packages. They also will start and put together CloudFormation templates that work to run the miner during the build. And then they go and deploy, and they crypto mine. And they put up a really cool pricing chart of the cost to the account holder of what it took when they were running these things. Everyone, if I didn't tell you who owned this, you might look at this and think that this was just any sort of cloud-based product, and this is what it took to run it. This was the infrastructure cost behind it. I can't stress this enough. This is how adversaries view us now. This is how adversaries view their targets when they're going through and building out their plans and building out these different codes here. And there's another little footnote dropped for this screenshot of this particular pricing scheme here, which says, in some of these instances, we went on the low side of the pricing scale. But the adversaries had full roles and full capabilities to scale up to extra large instances if they needed to. So this could have easily scaled exponentially if we needed to, just for the adversary to get back what they need to get back. And then of course I come back to the kind of old age question here, which is, if I've got this spinning up, how fast would it take my security team to know that this is up and running? But what I really like to focus on, and I'll go back to the screenshot one more time, again, if I took away the title of this and told you that this was not a malicious threat actor, and I just said, this is how we're going to build our next thing product. Drop into a VC meeting, slap AI at the key integrals there, and just say, here's how I'm going to build and do that next thing. I'm not far off from how these things are built and how they're put together. That's how adversaries view our cloud infrastructure these days. They view them as opportunities, they view them as weaknesses, they view them as attack vectors, as entryways to get into an organization. And quite frankly, and it's funny because there's some conversations I've had with folks who said this is amazing talent. This is talent that builds startups and builds companies and puts things together and solves problems and cures whatever. But that line, depending on where you are in the world, is very thin. And that's the part we've got to remember about these adversaries too. There's some great geniuses out there doing very, very malicious things. All right, last but not least, I drop in some mitigations in here as well, just in case there's folks who are having to go back and be like, all right, now I'm scared to death of the cloud infrastructure. I don't like what Matt said. We need to just burn it all down and come on-prem. Not the goal whatsoever. The goal is more about continue to build, continue to develop, but wrap security around these things. So first off is having an inventory. This is going to seem really silly because it's like, yeah, of course we have an inventory. I'm like, yeah, but do you? Do you have an inventory? Capture telemetry, discern between assets, and repeat that again tomorrow. And repeat it again tomorrow, and repeat it again tomorrow. And just keep going until you know what's inside of that environment. And then it gets really easy. And I say it like it's easy, but I approach things now from a very programmatic sense. Pull a list, compare it to yesterday. Is there a delta? What's the delta? All right, approved, move on. Understand how data flows back and forth. This one's probably the most intensive one. Understand where data is being sent, inputs and outputs. One of the things that I'm a huge fan of whenever data is sent from a place to another is the ability to configure a time to live on that data. Okay, I know I need this thing for 2 weeks while I'm building a development app out. In 2 weeks, I want it to automatically expire. I'm sure it's probably no surprise to anyone here the number of times that someone goes into an environment and finds unnecessary, unneeded dev instances, stuff that people who don't work here anymore deployed, a project we tried 2 years ago that failed. The numbers are way too high. Identity hopping is, again, another audit side of things. But I've already shown you there's adversaries who know exactly how to pivot through SSO. So we have to understand how and where that's federated, and test. If I have access to one account, does that mean I have access to many? Now, I will give a very, very fair shake to a lot of companies out there. I feel like we're right at this cusp of identity controls about to change. There's a lot of folks, I'll name Google in particular, just because now when I want to log into anything Google, somehow my YouTube app starts squawking at me. I need a YubiKey. I need my picture somewhere. There's all sorts of things that I got to say in the middle of a plane flight are a real pain in the butt. But I'm really happy that they're there. And I'm hoping that we start to go on this road of you need to have not just multi-factor authentication, but, and I dropped this in here too, star factor authentication. I want my industry, my company, to be able to lock that thing down as much as they want to. I don't want options. You can have a PIN or you can receive an SMS. No, I want both. Because guess what the cost is of losing access to this thing? Go ask MGM. Anyone see, there was an article I think yesterday or this morning about the cost, what the estimated cost is going to be for the breach that they went through. Anyone see that or know what that number is? It's going to be at least $100 million for them to go through and recover from that breach. Now, for those of you who are like, well, I bet the ransom was a lot cheaper. It probably was. But you know what else was cheaper than all of that? Securing and wrapping some security around those systems a little bit more. And again, not throwing shade, we're comparing numbers here. I promise you there was a PO in someone's inbox that was not $100 million that would have prevented or helped mitigate some of that. And last but not least, I'm a huge proponent of log all the things. You've got to have that telemetry that you can look back on and say this thing happened or this thing did not happen. Logs. I cannot stress that enough. You've got to have a way to actually create the visibility and create the insight that you're looking for. And last but not least, I couldn't go as far as without saying that don't forget that cloud computer is just using someone else's computer. At the end of the day, it is not their security. It's still your security. It's still your assets. It's still your things to work through. I tried to finish on time so that way I could get Josh up here as soon as possible. But with that said, thank you very much, everyone. And appreciate it. And thanks for the time. And if there's any questions, I can take them. But if not, I'll hand it to Eric to transition over. Thank you.